This is Zach, the PCB designer. The board is now fully placed with fanouts and breakouts completed. I have just joined another concurrent design session with my colleague Wilfred, who has just finished optimizing the FPGA pinouts based on the final placement and breakouts. We will now work together concurrently to route and tune both DDR4 interfaces. I will work on routing and tuning the DDR4 byte lanes of the hardware processor system, or HPS system. While I am working on that DDR4 system, Wilfred will be completing the routing on the second DDR4 interface for the FPGA fabric. Using the robust sketch route tool in Expedition Layout, I will route 4 byte lanes of the DDR4 HPS circuitry. Using sketch route, I will select a group of nets and use the F9 sketch route command to quickly route an entire byte lane with the power of sketch router. So selecting my first group of nets in the layout, I can then use the F9 sketch route command to complete the routes. If any nets were not routed during sketch route, I could use the hug route command to finish up any straggling nets. In this case, that's not necessary, as all nets were routed successfully with sketch route. So I'll repeat this process of selecting the byte lane nets in the layout and using the sketch route command for the remaining 3 byte lanes. Meanwhile, Wilfred is using the sketch planning functionality to efficiently route the 4 byte lanes of the DDR4 FPGA fabric interface all at one time. So I'm finishing up here with my last byte lane on layer 2. All of those routed. Wilfred is finishing up the sketch planning for the 4 byte lanes on layer 2 of the FPGA fabric interface. He'll select all the sketch planning there, and then using the F9 sketch route command, he can route all 4 of the byte lanes at one time. The sketch planning functionality provides a highly efficient method for sketch routing multiple interfaces all at once. So now that all the byte lanes on layer 2 for both interfaces are routed, Wilfred and I will start tuning them. Tuning parameters can be defined in the Tuning Patterns dialog of Editor Control. I can specify a slew of different tuning patterns, from tuning pattern spacing and shape to iteration count and length addition settings. Based on the defined tuning parameters, the Target Lengths tuning dialog gives us the ability to quickly tune the DDR byte lanes based on the target length of the longest signal trace. So closing the Tuning Parameters dialog, going to navigate to one of my byte lanes here on the HPS interface, select one of my nets, and open the Target Lengths dialog. So in this dialog, I'm going to sort the current column to get the longest length net and set that as my target net, and then use the Tune command here, which uses the tuning parameters we just saw in Editor Control to tune this byte lane based on the constraints set up in the Constraint Manager. We can see the current column shows all green for the byte lane I just tuned, meaning that we successfully tuned that byte lane to the constraints defined. So I was able to tune my net successfully on the first pass. However, it looks like Wilfred has a few nets that did not tune correctly on the first pass. Those are the nets shown in red of the current column of the Target Lengths dialog. So for those nets, Wilfred can now move on to the manual interactive tuning process and fix up those nets manually. We can see the tuning meter on his cursor there as he's manually tuning the nets, and the tuning meter will show green when the nets are successfully tuned within the constraints defined. So Wilfred has now finished the interactive tuning process, and we can see the current column there of the Target Lengths dialog shows all green, meaning that all nets have been successfully tuned according to the constraints defined in the Constraint Manager. I have now completed routing and tuning all byte lanes of the DDR4 hardware processor system, while Wilfred finished routing the DDR4 FPGA fabric circuitry. I can now move on to checking the defined constraints against the actual routed trace length values to verify tuning integrity.